Now let's look at another hot product, Visual C++.
Hi, my name is Denis Gilbert. I'm the General Manager of the Visual C++ business unit at Microsoft. Today we're going to be having a sneak preview at Visual C++ version 1.5, which is a new edition of our Visual C++ family, and it's going to be officially unveiled tomorrow during Devcast. So today, during the sneak preview, I'd like to give you a first look at it and try to show you some of its features, and hopefully you'll be able to find some of the things in it that will really make it a really nice product in your arsenal to develop business solutions and components very rapidly for your customers. The product actually released to manufacturing on December 1, so by the time you see the Devcast announcement tomorrow, it'll probably be just short of being available in stores. We're actually taking orders for it already, so this is not a preview of a future product, but rather something that exists today. This product is a 16-bit product for Windows 3.1. It replaces Visual C++ Professional version 1.0. There are three big bullet features in this new edition of Visual C++. The first is Windows NT hosting. What that means is that you can use this product on either Windows 3.1 or Windows NT to do all your 16-bit development. So if your preferred development environment is Windows NT, you can now use it for your 16 and your 32-bit application programming. The next big feature is full support for Microsoft's Object Linking and Embedding version 2, or OLE 2.0 for short. And you'll see in the next slide what I mean by full support. We've really taken the complexity of OLE 2.0 and made it almost a no-brainer to build very sophisticated, very complex, very interoperable components for your customers. And finally, database support. Database support is built right into Visual C++ 1.5. We include all of the necessary pieces from the Open Database Connectivity Kit. We include all the drivers, extensive support in the libraries, and in the Visual C++ wizards. Let's go back and look at some of the demand for these features and see how they may be applicable to your businesses. OLE is a feature of Windows applications that we found that only about 10 to 15% of our customers are implementing today. On the other hand, probably as yourselves would like to do, over 70% of our customers want to implement OLE in their applications, but they're a little bit overwhelmed by the complexity and the difficulty of adapting an existing application to OLE. You'll see how we can make that transition very, very fast and effortlessly. In terms of database support, across all languages, over 40% of our customers find themselves dealing with databases every day. And to this date, there hasn't been a single C++ compiler vendor that's built database support into their class library. Finally, Microsoft has provided this extensive database support both at the engine, the driver, and in the tool level to make it easy for you to rapidly develop custom solutions that use a database as the underlying file format. In terms of OLE, you'll find that OLE, if you look at the references and you look at the specifications, really consists of a large number of interfaces. Interfaces for drag and drop and proxies and marshalling and all sorts of very advanced and sophisticated services. But really what's missing from OLE today is a number of implementations for those end user features which people associate with OLE. And when I mean end user features, I mean features such as visual editing, the ability to edit something in place inside another document. Drag and drop, the ability to drag entire documents not only within an application but between programs. OLE automation, a replacement for DDE, which Visual Basic supports. The ability to call into another program and invoke methods and functions programmatically between processes. And of course, MFC and Visual C++ 1.5 support the OLE component object model and the structured storage APIs and formats of OLE 2. In fact, Visual C++ makes OLE easy. And the way it makes OLE easy is by providing those missing implementations of those OLE 2 interfaces that you need to be able to make your program be a visual editing server to support drag and drop, to support OLE automation. All in all, the work that we've done amounts to about 20,000 lines of C++ code added to the MFC class library. And you can think of this as 20,000 lines of code that you will never have to write if you want to implement OLE functionality in your custom solutions. It leverages MFC, so if you've invested in MFC and Visual C++, the transition is very fluid. The architecture of your program remains the same. You don't have to re-engineer all the investments that you've made in MFC in the past. And anything that, if you're a beginning MFC programmer, if you're thinking about adopting Visual C++, you'll see that the OLE classes and the OLE architecture follow very much the document view architecture that we've had in MFC for over a year. And finally, as with the database support, we include wizards to make it really easy to add OLE to an existing or new program and to automate methods inside a program using OLE automation. Let's look at a few of the database features before we step into a demonstration of the OLE stuff and the database stuff. First, we're including the ODBC engine, the actual DLL that supports the ODBC API, and many ODBC drivers to support common database formats. We include drivers for Paradox, for XBase, namely DBase and Fox files, drivers for Excel, formatted text, Oracle, SQL Server. So really a variety of database drivers for both local ISAM type and remote SQL type databases. So if your project or your next program calls for incorporating database support, you'll see that we have most of the drivers that you'll probably need for most of the common databases and a very fertile and active third-party program for finding other drivers for perhaps AS400 or HP or DEC database formats. We also include the Microsoft Query program, which is the same program that's in Microsoft Excel 5. And we include extensive support inside of MFC, inside of the class library, to provide database classes. So this is basically a C++ view of the ODBC API, and database classes which look very much like the ones that are exposed in VB3 and in Access. So if you're familiar with those tools, you can now use them together and using very similar concepts in terms of how you interact with your database. And as with the OLE support, we've modified the wizards to make it easy to bind a program to a database and to bind a user interface to the class created from that database. And probably the best news of all is the ODBC drivers and the ODBC engine can be included in your Visual C++ applications without worrying about runtime licensing or royalties or any of that. They're all royalty-free, redistributable binaries. So let's look at how Visual C++ 1.5 can be used to build custom solutions that incorporate database and component features very, very rapidly. So I'll switch now to the demo machine. In fact, to the Visual Workbench. And for those of you familiar with Visual C++, this is the professional programmer's editor where the debugging and the building takes place. And what we'll do in this demonstration is show you how you go about building a database browser that incorporates OLE support. Now, for sake of expediency and time, we're not going to do all the compile, debugging, linking steps on stage. I have the program built, but I'll just show you some of the steps required to build the program that I will show you in a few minutes. First of all, App Wizard is a tool to create new applications for Visual C++. And we've added a couple of new features to App Wizard. In this case, we're going to be putting our program in a broker directory. Let me just move up to the home directory here. And this program will be a stock browser. We have a little Access database of stock information. And then we'll set some of the options for our program. We've made it really easy to use the DLL version of the class library. This was a much requested user feature. Right now it's just a checkbox away in the options. Features like MDI support, toolbar support, custom controls, printing, context-sensitive help are just available via a mouse click away. And you'll see that there are two new buttons on the App Wizard page. One for Ole, where you can create containers, things in which you can embed Ole objects, servers, things which can be embedded in containers, full servers, which are servers that can work both standalone and can be embedded in other containers, and hybrid programs, which can be containers for other objects and embedded objects in other containers. Microsoft applications are container server applications. They are both embeddable documents and can embed other document types. In our case, we want to build a full server, and we want to support Ole automation. Keep in mind that the only thing I have to do for this program to support visual editing as an embedded server with menu negotiation, toolbar negotiation, is to check this radio button in this one dialog. That's it. No more work is required. You'll see that to build cutting-edge applications that use the sophistication of Ole has never been easier. The database options are similarly easy to use. We'll specify that we want to use a database with file menus already populated, and we'll attach our program to a data source. App Wizard finds the ODBC databases on my machine. I select the stock markets database, and I bind to a table inside the stock markets database. In this case, I have only one table. App Wizard then creates a C++ class for my table, so I can now start thinking of my database really as just another C++ class in my program. And that's it. That's really all the steps you need to do to create a fully functional program that works as both an Ole server, as an embeddable visual editing object, and is already bound to a database. In fact, all we need to do to finish this program is to add a user interface to it. So we'll create the project, and it will be loaded inside the workbench with all of the files, the readmes, the resources, and the dependencies figured out. And then we'll use App Studio to create a user interface for our stock database browser program. So we'll click on the RC file, the resource file, which contains the user interface, to bring up App Studio, which is our visual resource editor. App Studio is used to edit all of the visual objects inside our program. And as you can see in the browser here, App Wizard has already created many of the stock items that we already need, the menus, the icons, the about box, and so on. So in this case, we'll edit our form and add a little user interface for our database browser. So to do so, we'll add a label. This could be our stock symbol, for instance. We'll add a display field here, which will be used for the value. And then we'll simply clone these two commands, or these two controls, to display the high, the low, and the close for the stock in question. So we'll relabel these fields, low and close. And just to make things pretty, we'll add a little group box around it. Oops. I'm trying to grab the handle there. Come on. There we go. We'll size that over to the right. There we go. And we'll call that group box last week's results. Now, in a traditional visual C++ environment or other similar programs, I would now have to go back to the workbench and add some code to bind this form to my database and to the underlying C++ code. With the new Visual C++ 1.5, all I have to do is control double-click on that display field, and it will automatically be bound to a column inside my table. In fact, it goes a little bit further than that. It picks the best match based on the label for the display field, the M symbol entry in my C++ class, and this is exactly what I wanted to do. And I'll do the same thing for my high. Again, it picked the right value, the weak high member variable. The same thing for my low, and the same thing for my close. So I'm done. I've actually finished my program. All that's left to do is to compile and link it. But as I mentioned earlier, I already have that program built so that I can go on to the next steps. So before we go on and make our program a little more sophisticated, let's see what we would have if we were to compile and link that program. So here is the program exactly like the one that we just built. It's an MDI application. It's got a fully functional toolbar. I can create new windows, and I can use the window menu to rearrange, that is to cascade or to tile the windows. The toolbar can be cycled on and off using the view menu. The status bar at the bottom can be turned on and off, and so on. The file menu is fully populated. It's got open, print, save as, close commands. They're all wired up where appropriate to common dialogues. And finally, here is our form displayed inside one of the windows, and I can use these database navigation buttons to browse through my database. The controls inside the form are automatically bound to the corresponding fields inside the database. So here it is, a fully functional, very nice looking MDI Windows program with all of the standard Windows dressings, the toolbars, the menus, the MDI, and so on, and it's completely wired up to a database. Keep in mind that we also built this program as an OLE server, and you'll see in a few seconds how this program can be used in many other contexts besides by itself. So let's bring up our development environment again, and we'll make our program a little more sophisticated. In fact, we'll take this form that we just created, and we'll add a few calculated controls to it. What I'll do is I'll select this group box and all of the controls inside. First, I'll resize my form. And I will provide some controls to show the last year's results for each of these stocks. So I'll select that and clone it again to the right. Clone the group box. Okay. I don't need a close field because close values don't make much sense for a 52-week number. And I'll size it up, move these controls up a little bit. And just to make things interesting, I'll add a list box to show you how I can bind more sophisticated controls to database functionality. Now, let me click on this high value. AppWizard thinks I want to bind this value to my week high variable, but in fact, I don't have a year high variable. But it's very easy to simply type one in. We'll call it type double. And this will automatically edit my class that maps to the database to add a calculated field to it. And I can do the same thing for my low value and for my list box. In fact, what's really happening behind the scenes is that Class Wizard is creating member variables for that class. And here's the new member variable that I've just created for my year high value. You'll notice that Class Wizard uses the new tab dialog boxes, very popular in Microsoft Office applications, and it makes it very easy to select entire dialogues full of information simply by clicking on these sort of recipe card tabs up here. In fact, as you saw before, here are the member variables. Message maps are defined the same way. Message maps are means to add handlers for commands. So if I want to handle the close command from a window, all I have to do is say add function and then jump to code to go edit it. OLE automation is handled similarly. If I want to use OLE automation to call into my broker program, all I have to do is add a class to contain the OLE automation methods, derive it from any one of the MFC existing classes, in this case a very generic class, tell it that it's OLE automatable, and that it can be created out of a program like Excel or VBA using the public name stock. Okay. In fact, to support OLE automation, you can think of it as just a means of exposing a program's member functions to the outside world. The way you do that inside of Visual C++ using the Class Wizard is by saying add method. So you can just say something like find stock is going to be the external function name. Its return type is a Boolean. And the parameter is a variable called symbol of type pointer to string. So we've just added a C++ member function that is OLE automated for the outside world to call. And to edit its code, I click on the Edit Code button, and voila, all of the OLE2 plumbing, the GUI registration, the message mapping that maps the OLE automation methods to the internal methods, All of that code has been provided for me by the wizards. All you have to do as programmers is do what you do well, figure out how to return whether or not that stock really exists in the database, and you don't have to worry about any of the old A2 gadgetry or plumbing in between. Adding variables is handled very similarly, and they're called properties. So I can add a property via OLE automation called week high. We'll say it's a member variable of our class, it's of type double, and that's it, it's done. Using OLE automation, I can get at those week high values very, very directly, and I have no other code to write. I can add other properties that are accessed via functions. So I might have, for example, a year high value, which is accessed via a getSet method. It's also of type double, and the two functions that will be created are get and set year high. And similarly, I can just hit edit code and go and add some code to get and set my year high values. Now let's see the program that we've just built. Here is our new broker program. Now it's got those calculated fields on the right-hand side over here. It's got the list box that shows the 52-week values for the stock and the navigation buttons for navigating through my database. And you can see that the high and low values are calculated. All in all, there was about 30 lines of C++ code added to bind these controls to C++ functions. But the really interesting part about this program is that it is now an OLE2 server. So let's see how it is used in context of other programs. What we'll do is we'll run Excel 5. And we'll show you how we can use Excel 5 and Visual Basic for applications to glue together components using OLE2. And you'll see that this may be a very effective means for you to create custom solutions using off-the-shelf applications. So what we'll do is we'll open a spreadsheet over here, which at first glance will look like the same stock information that we have inside our Access database. But you'll see that we're actually using OLE automation to get the data out using our C++ program. Here is the stock inside the database, the week low, week high, and week close values. Behind the scenes is a Visual Basic for Applications, or VBA script. The VBA script uses the VBA command create object to create an instance of our Visual C++ OLE object. It then uses the find stock method, which we added, to return true or false if the stock is in the database. And then it uses the week high member variable to get the week's high values for each one of the stocks. And just to show you that this program is actually running live, I'll change the VBA script and ask for the year high values, which were calculated values. I'll switch back to my spreadsheet and watch what happens when I hit the recalc button on my week high column. It goes out to the database, and via my OLE automated object, it calculates the year high values live using OLE automation. So a fine example of how you can use VBA and Excel and Visual C++ and ODBC to rapidly create pretty sophisticated functionality. Recall that we support visual editing, so I can use Excel's insert object command and insert my broker document inside the spreadsheet and use visual editing. In fact, you'll see that I've now got Broker's toolbar up here. It's been automatically negotiated on my behalf. It's got Broker's help menu, but it's still got Excel's file menu. So all of the standard OLE2 in-place editing functionality has been provided by Visual C++ and MFC. Clicking outside of the object leaves behind a meta file representation, and we're using a little chart of the stock's value. Double-clicking on the object again brings up in place the broker's user interface. All right, let's have a look at another example of a program built with Visual C++. And this is an example of a program that is actually a container. This is a simple object-oriented drawing program, and you can create on the canvas objects of various shapes and colors. But recall that we support the building of OLE containers. Remember back in AppWizard, one of our choices was containers? As a consequence of doing that, the programs you build have an insert object command of their own. So now I can go out and I can insert Excel inside of my application. So this is an example of using applications as building blocks for custom applications. In fact, now my chart is in place inside of my application, and you can think of it as being a charting custom control, but a very sophisticated one at that, because it really is Excel with tooltips and tear-off toolbars and all of those features. Similarly, as in Excel, clicking outside of the context of the object reactivates my container, and I'm now free to go and work on the rest of my canvas. And in fact, I can even use the insert object command again and insert in place the first program that I built, the Olay server, the broker object. Let me move it out of the way, double click on it to activate it, and now I've got broker's toolbar up here again and broker's menus. Clicking outside of the object reactivates my container program. So let's switch back to the slides, and I'd like to sum up with 3 points. If there's anything I want you to remember from this demonstration and this preview, is these 3 points. First of all, Visual C++ 1.5 makes it incredibly easy to build high-speed, reusable components using Olay 2 as the plumbing in between these components. Visual Basic makes it really easy to use these components. Applications can use these components. Applications themselves can be used inside the containers that you build with Visual C++ 1.5. Finally, this is the first time a C++ compiler vendor has actually added database support to its class library and to its development system. So you have one-stop shopping for all of your C++ database development needs. And finally, one more finally, this is your safest investment for the future in terms of a tool set. We've protected people's investments in Microsoft tools, in MFC, for over 2 years now, specifically in the case of MFC, from C7 to Visual C++ to 32-bit edition to RISC editions, and now you can move to database and Olay 2 functionality with a recompile. It's really no more conversion effort than that. And we're committed to protecting your investment through all future generations of Windows systems. So I hope that you've really spotted a few features and a few things in this product that will really create some opportunity for you as solutions providers, and I wish you all the best of luck for '94. Thank you very much.
Well, now it's your turn. Give us a call. We'll try to answer your questions.